everyone, in this video we are learning first law of thermodynamics in detail, in which we learn internal energy, work of a system, core idea of first law of thermodynamics, and also we study the first law of thermodynamics with respect to the law of conservation of energy. Okay, so let's begin with the definition of thermodynamics. Okay, so question is, what is thermodynamics? Exactly, thermodynamics is the study of energy and work of a system. So in context of thermodynamics, particularly when we talk about energy, we mean heat energy, right? So intuitively, the word thermodynamics means the flow of heat, as therm means heat or thermal, and dynamic means flow. So the meaning of the word thermodynamics is the flow of heat energy or the flow of thermal energy. Now come to our main topic, that is first law of thermodynamics. To understand the first law of thermodynamics, it is important to understand the internal energy first. So internal energy, in a very simple way, is the total energy of a system. Now suppose that we have a system. This is a system. It has fixed boundaries, right? And it has the matter inside, and the rest is the surroundings. Okay. So now the aggregate energy, or you can say the total energy within this boundary, inside this boundary, the total energy is called internal energy. And all other energies across this boundary is called external energies. Right? So this is I think it's a very simple explanation of internal energy, right? So internal energy is denoted by capital U. This is the widely used denotation for the internal energy. Okay, internal energy is measurable and it is the state variable of a system. A state variable is that variable which used to describe the state of a system. Okay? Alright, now returning to the first law of thermodynamics, which states that the change in internal energy of a system is equal to the difference of heat added into the system and work done by the system. So mathematically, we can write the first law of thermodynamics as delta U equals to Q plus minus W. Alright, so here delta U means change in internal energy. Remember, internal energy is a state variable. Therefore, change in internal energy means change in the state of a system. Internal energy of the system can change by the exchange of heat energy or work done of a system, right? And Q represents heat energy. When heat energy is added into the system, we use positive Q, and when heat energy is extracted or ejected from the system, we use negative Q. At some places, we can also denote heat energy by small q also. Now W. W means work done of a system. In context of thermodynamics, work of a system, in context of thermodynamics, work of a system means two things, either by the system or on the system. So by the system means negative W, on the system means positive W. Okay, so by convention, we presume that when gas expands, work is done by the gas. However, when the gas contracts or compresses, work is done on the gas. Did you know that this work done is also called work energy of a system? Work energy is the amount of energy that has consumed in doing work, either by the system or on the system. Now we understand the first law of thermodynamics with respect to the law of conservation of energy. Okay, so law of conservation of energy says that energy is conserved. It can be converted from one form to the other. It is believed that the first law of thermodynamics is the restatement of law of conservation of energy. So let's see how. Take an example. Suppose that we have a room, an ordinary room. Inside the room, we have a machine, an innovative machine which is called heat work machine, HW machine, HW for heat work machine, right? So this heat work machine requires heat energy as input and produces work done as output. Heat energy in joules and work done in joules too, right? And we have a machine operator, right? So this is the scene. At day one, the machine operator inputs 10 joules of heat into the machine and receives 1 joule of work in return, right? On day 2, the machine operator input 20 joules of heat energy into the machine and gets 2 joules of work in return. Also, the operator sensed that the room temperature has increased. Now at day 3, the machine operator this time inputs 50 joules and gets 5 joules of work in return. 50 joules of heat energy and gets 5 joules of work in return. But this time the machine operator feels that the room gets too hot. Soon the machine operator realizes that the energy he is providing to the machine does not entirely convert into the work. However, some energy convert into work and some goes into the surroundings, increasing the room temperature. So the conclusion from this entire example is that energy does two things: productive work. In productive consumption, we can say, I think consumption would be more better word to explain it. Productive consumption of the energy and unproductive consumption of the energy. In this example, productive consumption is of work and unproductive consumption is the heat that is spreading in the surroundings, right? So remember that, okay, but the total amount of energy is conserved and equals to the sum of the productive work, productive consumption and unproductive consumption, which means that total energy is conserved. It cannot be created or destroyed, but it transforms from one form to the other, right? Okay, now look at the first law of thermodynamics. The first law of thermodynamics says internal energy equals to Q, since in this case work is done by the machine. So we use negative W, and if I tweak the equation in a way as this. So here you can notice that heat energy is converted into internal energy, and this heat energy is also converted into work, or you can say work energy. So this can be unproductive and this is productive, because we really, by adding heat into the system, we want the system to do work, but we does not meant to increase the internal energy, generally speaking. So this is the unproductive consumption and this would be the productive consumption. So the point is, in the first law of thermodynamics, again heat energy has been converted into internal energy of the gas and mechanical energy. But the total energy, if we sum the internal energy and the mechanical energy, we get the amount of heat energy. Thus energy is conserved. Lastly is the core idea of first law, is that energy is conserved, as we have just seen in our heat work machine. and as stated by the universal law of conservation of energy. And of course, in context of thermodynamics, heat energy is converted into mechanical energy or work done. So this is the core idea. So all done. I hope this video helped you in studies. And yes, I upload some thermodynamic info bits on the Facebook pages, link in the description. And if you would like, or if you have time, so go through those info bits also. And yes, please provide your feedback. Your feedback is important for me to improve the videos. And if you have any confusion or question, feel free to ask questions regarding the content of this video via email, comment or message, any means suitable to you. So good luck, study hard, and thank you for watching the video.